Good afternoon, ladies and gentlemen. Welcome to Building the Asset Performance Loop, supported by government funding. Our presenters on these topics today are going to be James Reyes Pinknell of Conscious Asset and Igor Shigrin of Fair Grant Writing. And without further ado, I'm going to ask James to jump in and get straight into our topic for today. James.
Well, thank you very much, Colin. I'm hoping that you can see the first slide of a PowerPoint presentation on your screen.
Yes, we can. Yes, we can. Thank you.
Thanks. So what I'm going to talk about today is asset performance management. And at the end of it, I'm going to ask the question, are you ready for it? Now, I've used the term, are you IIOT or Industrial Internet of Things ready? That's really only a piece of it, but it's perhaps the one piece that's best known. Now, my own background, I'm an engineer. I've been doing consulting and training in physical asset reliability and maintenance management for the bulk of my career. I've authored several books that are used to help train maintenance managers and work on business cases. And of course, the latest hot thing out there these days is the Internet of Things with lots of hype, which in all honesty, I have been wondering about. So I've done tons of research on it, and some of that will be presented here today. So first of all, what are we talking about with asset performance management? So first of all, I'm talking about physical assets. So your plant, your equipment, your mobile fleets. And they have three distinct activities that have to be done well in order to achieve maximum performance, maximum output, if you will. First of all, they must be designed and fit for purpose. So they must be actually capable of doing what you want them to do. They must be operated in a way that won't actually harm the asset. So once you've got an asset that can do what you want it to do, you turn it over to operations. It's quite common to want to sweat the asset, get the most out of it. But if you push it too hard and you exceed its capabilities, you will break it. And that will show up as some form of a failure. And maintenance can't do anything about that. If you break it by the way you're operating it, maintenance can only return it back to service and let you operate it again and hopefully not break it the next time. Maintaining it is more than just fixing it. When I say maintaining to sustain capabilities, I'm talking about doing the proactive things that you must do, say vibration analysis or oil analysis, keeping oil levels topped up. Those are things that typically maintainers will do to monitor the performance of that asset and keep the asset in good operating condition. And those requirements don't vary from asset to asset, regardless of whether it's a truck, a factory, a pump in an oil field. It makes no difference. It must be capable, it must be operated within its limits, and it must be maintained in order to sustain that operation. Maintaining involves resetting, if you will, the asset back to its capability, given that it will naturally deteriorate as you use it. So we have three management activities that are often managed separately, but they need to kind of work together here. One is good life cycle asset management, and particularly at the design stage. You want to pick a design that's going to be suitable for the purpose and quite capable of lasting reliably for a long time. You want good operating practices. So you don't want to put people in the field operating your asset that don't know what they're doing. You want them to be trained on the asset and the processes so that they actually operate them properly and avoid breaking them. And then finally, you want a maintenance program that is right for the asset. Now, that's a concept that a lot of people don't think about. They understand that when something breaks, the maintenance department comes in and does a repair. And indeed, repair work is part of maintaining an asset. You're actually restoring its capability when you do that. But there's a lot more to maintenance programs that is proactive. And it's that proactive work that we want to leverage the most in asset performance management here. I'm going to assume for the rest of this talk that the design is capable, that your operating practices are actually going to treat the asset properly and not abuse it. And then we're going to focus on the maintenance program and executing it the right way. And the emphasis in there is not so much on the repair as it is on the proactive aspects that tell us when the asset is deteriorating so that we can act on that and keep it running rather than waiting for it to fail. So how does asset performance management fit in here? I've talked about doing the right maintenance and then, of course, doing it the right way. Now, on the right here, I'm not going to get into too much technical detail, but so don't get too afraid by this diagram. There are 6 patterns of conditional probability of failure over time. These were uncovered in the 1970s in a study of aircraft failures that was done by a couple of gentlemen at United Aircraft. And the findings of that particular study resulted in a method being developed for identifying the optimum maintenance program for aircraft. And they called that method reliability-centered maintenance. Now, I'm not going to teach RCM here, but there's important things to notice on these 6 patterns. The probability of failure changes over time in all 6, all but one of them over time. And the first 3, you'll notice that at the right-hand end of the diagram, the line or the slope of the line is actually increasing at the right-hand end. So with time, those failures in those assets become more likely to occur. So those are typically referred to as aging type of failures. The probability of them failing goes up with time. The bottom 3 don't exhibit that though. As time goes on, the probability of failure remains pretty constant. D is fairly typical in hydraulic and pneumatic systems. E is totally random. The old incandescent light bulbs exhibited this. You could put one in brand new and it would go out right away. Or it could be in there for years before it failed. It was totally random. You had no way of knowing when it would break. And the bottom one, of course, is worse when it's new. And this typically happens because we've upset the system in some way. We may have done an overhaul or a repair and made a mistake. The percentages that you see there indicate the percentages of failures that exhibit the different characteristics. You'll notice that the first 3 only account for 11% of the total. The rest of it is all more or less random, and the biggest chunk by far exhibits infant mortality. And that's a result of us interfering with operating systems too much. So we want to make sure we're doing the right maintenance. So we don't want to overhaul things that are going to exhibit that 6th pattern. Where we have totally random characteristics over time, we don't want to try preventive replacements or restorations. Those will work for those first 3 patterns where aging is a factor, but where aging is not a factor, preventive replacement or restoration actually does no good. And if you have the 6th condition, it'll make things worse. So we have to make sure we're doing the right maintenance. The 4 strategies that you have are to just let it fail, run it to failure, and that sometimes is appropriate where the assets, the consequences of the failure of the asset are acceptable. We can prevent failures with restorations or replacement activities, what you might call an overhaul, for example, where we have those first 3 patterns. For all of the patterns, we're likely to get some indications, early indications that the failure has begun. And that's where condition monitoring comes in handy. Asset performance management is based very, very heavily on condition monitoring concepts. And I'll explain that in the next slide a little bit more. And then the final one is detective maintenance, where we're actually testing dormant devices to look for things that are already failed. This is like a test of your smoke alarm at home to make sure that it actually still functions. If you find that it's not, then you change it. And by doing that more frequently, you find it failed, more likely to find it failed before you need it than after you need it, which is too late. This slide shows the concept of condition monitoring, and what we have here is a graph that shows the level of performance over time, or operating age of the asset. Every asset, if it's designed properly, has this built-in capability that is higher than the performance that we want from that asset. As we use the asset, it will degrade slowly over time, not necessarily on a straight line, but as we operate it, it will degrade and eventually reach a point where its capability is just at or below that desired performance. It's not able to do what the operators want it to do at that point. And it would make sense if we catch it just before we get here to maintain it at that point and bring it back up to that initial capability so we can continue operating with minimal disruption to the operation. So we would take less time, do a less extensive repair at that point in time. Asset performance management is all about catching things before they get to this point here. If we fail to do that, then the asset continues to operate, and now you'll notice that its capability, which is represented by this sloped line, is less than the desired performance. So we're actually running it beyond what it's capable of doing, and it'll the degradation will accelerate until it's totally failed or dead. That's when you have to do a repair. And that always happens when the equipment's been running and doing something you want it to do. It can't fail if you're not using it. So it's always disruptive to your operation and costly. And of course, it can create secondary damage. The repair is going to be more extensive than had we done it proactively. And it's likely to take longer in time. Oops, let me back up a bit. I hit the wrong button. So what we want to do with condition monitoring is monitor its performance as it's degrading, find where it is along this line, and when it gets close to this point where we want it to be proactively repaired, we take it out of service, act on it at that point in time, and do the minimal type of repair. Now, condition monitoring has been around for a long time. When I was very young as an engineer, I actually used to take around a screwdriver and listen and hold it up to the bearing housings, and I'd hold it up to my ear, and I could actually hear problems in the bearings. It's not sensitive to all the failures, but it was a good indicator, and it was a very crude form of using the human senses to monitor conditions of assets. Some people still do that today. Checking oil levels is another way of monitoring condition, watching temperatures, pressures, and so on. It works very well if it's used faithfully. It can be a bit labor intensive, even if we're using fairly complex technology like the sensor that's being used in this picture here. He's actually listening or looking at vibration levels on a housing of a piece of equipment near the bearing. So he's actually looking for signs of problems in that equipment, and he's using a portable device. If he's found a problem, he'll now report that back to the maintenance system, and a repair will be scheduled. You can monitor with installed systems, but that can be, oops, I did it again, quite expensive. The wiring in particular for that is quite expensive. And the training needed for this guy to do his job properly is fairly extensive. It's specialized and can be also quite expensive. So that's condition monitoring. Now with asset performance management, we're adding in some of the Industry 4.0 capabilities. We're still going to have this condition monitoring activity, and we need to have this condition-based monitoring mindset. So we have to be good at recognizing that we can find problems early, and that when we find them, we need to act on them fairly quickly. We're going to enhance that using devices that are installed. The Industrial Internet of Things is producing for us a large number of devices capable of monitoring machine condition as well as process performance parameters and conditions. We feed all that into software that can make decisions for us. In the old days when I was listening to pumps with a screwdriver, if it was very, very noisy and rough sounding, I knew I had a problem. Well, if I could feed that same signal or an equivalent of it from an Industrial Internet of Things device into some artificial intelligence, it can tell for me that I have a problem. And once it's identified that problem, it sends a notification of that over to my maintenance work management system, where I manage the deployment of my workforce to go out and investigate the problem, and if necessary, to correct it. So I've got various pieces of this puzzle working together. Condition-based monitoring and mindset. I've adding in some fairly sophisticated software technology to help make decisions based on what I'm finding in the field using all these new devices. And then when I find a problem, I'm telling my maintenance system about it so that I can actually act on it. Now here's a slide comparing conventional condition-based maintenance with asset performance monitoring. On the condition-based side on the left, we have a combination of manual monitoring of signals using our human senses. We can touch things, we can feel when they're hot, we can hear when they're noisy, we can feel vibrations, for instance. We can use technologies that are handheld and carried around in the field, as that picture of the technician showed in the earlier slide. We can use ultrasound that way. We can use infrared imaging and look at infrared images on a screen in the field. We can monitor vibrations, or we can simply use a checklist on a clipboard or on a tablet today that records various readings. We take those back to our maintenance system, and where we spot a problem, we spot a signal that's out of the normal range, we can then identify that item as needing work, all right, and that triggers a corrective action. We can also supplement that with installed continuous monitoring, usually through wired connections. Those systems tended to be quite expensive and typically were used extensively in very critical equipment, say compressors and major pumping systems in a refinery, for example, where the cost of downtime was very, very high and could justify the cost of making this expensive installation in order to monitor our equipment. But a lot of companies couldn't afford that, so the continuous monitoring wasn't done in many cases. The software needed, if you're using, say, vibration analysis or infrared or ultrasound, you need to know how to use it. There's training involved, and typically software that processes the raw signals, right? Even with ultrasound, there's a technique known as heterodyning that takes the ultrasound, which is outside our audible range, and converts it to a signal that we can hear so we can listen to it on a headset as we're walking around in the plant. So there's quite a bit of technology involved in these condition monitoring systems. The maintenance technicians that do this work rarely actually look at process indicators. So your process, the thing the operators are looking at where they may spot problems, is often ignored by the maintainers when we use conventional condition-based maintenance, because the maintainers are not trained how to operate the process. They don't really know what it should be doing. They only look at the equipment itself and whether or not it is showing signs of distress. So the technicians themselves, now they could be trained in-house people. I've got a colleague who runs a business that actually has technicians who are skilled and trained using their own devices, and they contract their services to customers. If you have installed continuous monitoring, it may be monitored by your own technicians, your own software on site, or it may be monitored by technicians someplace else. I've got another colleague who has that type of monitoring done. They install devices in the field, and their monitoring staff, basically an office full of very well qualified engineers, is actually based on the other side of the world, monitoring signals for their customers and identifying when there's a problem and telling the customer about it so they can act on it. That's conventional condition-based maintenance with a fairly strong technical addition to it. Asset performance monitoring today goes beyond that. Much of it is going to be installed with continuous monitoring. The difference is using the devices that are available today, which are being referred to broadly as the industrial Internet of Things. Many of those are wireless, so they communicate not across a wired system, which keeps costs down, but through your networks, either using Bluetooth or Wi-Fi type signals. They often also have a little bit of intelligence built into the sensors. Condition-based maintenance in the conventional sense did not have that. The sensors themselves just picked up a signal. The conversion of that signal into something that we can interpret as a human or into a condition that we can actually make decisions based on, was typically done in an analyzer, which might be in the field or might be carried around in the field, as I once did, or installed in an office someplace, looking at the signals that come by through its wired network. Today, the devices, the monitoring devices in the field actually have what they call edge computing. They're at the edge of the network, and that's where the name comes from. There's a little bit of smarts built into them, so they can tell after a period of running what normal is like for that equipment. So they actually learn what the normal signals are after you install them. And after a period of learning, they can now detect anomalies. Now, if a failure happens while they're in that learning phase, you kind of have to tell it that was a failure and let it start learning over again. But once it's learned successfully, those devices can tell you about problems that arise in the field by looking for exceptions. And they typically only send the signal across the network to tell you there's a problem when those exceptions show up. They do that because they're now monitoring continuously. There's a tremendous volume of data being generated, and most networks just can't handle that volume. So by using edge computing, we reduce the load on the networking that's needed to support these systems. Now, the nice thing about having all these signals going electronically by exception only is they could also go around the world to somebody to look at. And if more in-depth analysis was needed, they could, through that same network, go back to that field device and do more in-depth analysis on the signals that are being picked up. In between, we use artificial intelligence, or its subset machine learning, to understand the various patterns that are being revealed by the signals. I knew as a vibration analysis that if I had a high 1 times running speed vibration in the axial direction, in the radial direction, that I had imbalance. If I had a 2 times vibration, running speed vibration in the axial direction, I had misalignment. Those are patterns that you can teach the software. The software can also learn patterns that we may not have been aware of, and more by correlating various patterns that it sees at one device with, say, process operating parameters. It can actually tell when failures are starting to occur and forecast more accurately when those failures will actually take place. So it actually gives you a forecast, not only that you've got a problem, but how much longer you can expect to run before that problem results in a failure. That's something that most technicians doing condition-based maintenance are very, very reluctant to provide. They don't like to make that forecast because it's really, their crystal ball is not typically all that accurate. With the artificial intelligence and the capabilities of software to analyze these signals, you can actually get quite accurate with it. And then, of course, produce an automated output to your maintenance management system where you can tell people, hey, you have a problem, you better go do something about it. So it triggers action. Now, this is what one of those systems might look like, and I'm going to walk you through it a little bit here. On the left, you've got various pieces of equipment in the field, and installed on those are sensors, and I've shown them here like a network symbol to indicate that they're sending a wireless signal off to your network. On this bottom one, we have a fault. And that fault is being seen to be an exception, and it's sending a signal off to your network. There may be some additional signal processing or just transferring it into your asset performance management software. This is where the artificial intelligence and machine learning is even more well developed to correlate with what you're seeing coming from your process. Okay, the device itself may have some edge computing that says, I have a signal that's higher than normal. When I get into my asset performance management software, I'm now using the correlation capabilities of my software to compare with process operating parameters and say, historically, when I've seen this signal, I've had failures. I better tell somebody about it. And it now tells my planner or my field supervisor through the maintenance system that there is a problem. Supervisor investigates or sends somebody to the field to investigate and ultimately to work on and correct that fault. So a very simple closed loop system, very much what we used to do with condition monitoring. Big difference is installed, wireless, not a person walking around. Now, having said that, there are a few types of monitoring technologies that cannot be done this way. that still require a human. So you don't eliminate all the people from condition monitoring here, but you do dramatically reduce the demand for them. And you increase substantially the ability to forecast problems here because of this ability that the technicians didn't have to compare problems coming from the field with observed patterns that might be showing up in your process. So the impacts are that we're using these devices and software. We're replacing some of the technicians for some of these technologies. For example, vibration, infrared, temperature, ultrasound, sound levels. We don't really need people in the field to do that anymore. But things like oil sampling, non-destructive testing, which is often an inspection physically disturbing the equipment, various visual inspections of internal components, they still require a human being. Because the Internet of Things devices tend to be less expensive, we can do a lot more monitoring on a lot more devices than we could have done historically with condition-based maintenance in the traditional sense. We can correlate machine condition with failure history and process parameters. That gives us the ability to spot problems that we would likely have missed using condition-based maintenance and only maintenance technicians. So we can correlate various signals and get some very interesting information. Not only do we forecast failures, but we actually estimate remaining life, which is something that most condition monitoring systems conventionally cannot do, or if they can do, nobody's very comfortable with it because they don't really have much more than gut feel to go on. So the questions that I'd like to pose here is, are you ready for it? First of all, if your maintenance management system and your way of managing maintenance is very reactive to breakdowns, you're going to have to fix that. You have to get into a situation where you can, in fact, respond to indications of problem that are coming early before the equipment fails. So you want to be proactive in your mindset. If you've got a condition monitoring program today, are you truly trusting it? Do you actually respond when it shows problems? Some organizations don't do that. They monitor the conditions, but then ignore them and wait till things fail. And then tell you, well, we knew that was going to happen, but there's no value in doing that. The technology itself, a lot more sensors, wireless coverage is going to be necessary, of course, in the plant. And that can be done mobile. Many mining companies are doing this on mobile equipment with onboard telecommunications to get the signals back to monitoring stations. Are you willing to connect your process data and your maintenance data through this artificial intelligence and machine learning type of software package? Are you willing to do that? Recognizing that your process controls today may not be connected to the internet. And once you start connecting things up here, you're going to expose yourself to the internet and some cybersecurity threats potentially. And are you willing to take external inputs, so some smart computer outputs, and put that into your maintenance system to trigger actions as opposed to having a human do that? Are your people ready? Do they understand reliability and what they need to do to achieve it? Is the technical prowess there to manage this new technology? You might need more IT support than maintenance field technicians. The good news about it is that the people that are typically being hired today come with much more, I'll say, pre-installed tech capability than they did when they were in my generation coming into the workforce. So you're actually making better use of the type of worker that's easier to hire nowadays. And are you actually ready to trust artificial intelligence and machine learning? It is well proven, but until you see it, it's a bit hard to accept that it actually works for us. So those are areas where I think one needs to think about before saying, yes, we're ready to do this. Process, technology, and people. So that's what I wanted to present on asset performance management. I hope I haven't run overtime by more than a minute or two. And I'd like to, I guess I'm open for questions, but I think, Igor, you have something to say too.
That's right. That's right. Thank you very much for the presentation. Let me just switch to my PowerPoint.
Okay. And while Igor is doing that, ladies and gentlemen, please feel free to put your questions in the chat. And at the beginning of the question and answer period, we'll just get straight into them from the chat. All right. Thank you. And thank you, James, for a very interesting presentation there. I'm sure I do have a couple of questions coming out of that, but I'll address those later. And with no further ado, I will invite Igor to make his presentation. Igor.
Fantastic, thanks, Colin. So we'll get started. Today we will be specifically talk about the government funding, government grants for things such as software development, software implementation, technology implementation, software and technology training, because APM type of solutions, they are kind of software solutions. So these type of solutions may qualify for the government funding. Obviously, there's more funds and there are more grants than just for the software, but just for the sake of our webinar today, we'll focus on those, and I'll quickly then tell you at the end what else is available out there. Quickly about fair grant writing, our mission is to help Canadian businesses survive and thrive by unlocking their access to the government funding. And what we value is the strategic approach to your business funding needs. So that means that we don't just write the grants here and there. We try to understand your strategy and then align the government funding with your overall business strategy. We've been in business since 2013 and secured millions of dollars of grant money and interest-free loan money to our clients. And we try to minimize the time the client spends with us, because we know everybody's busy, even though, and especially nowadays when some people are forced to work from home. A couple of notable cases of our clients to share. We've secured $3 million in interest-free government funding to the aerospace manufacturer in Vaughan, and over $300,000 in government grants for a metal fabrication plant in Kitchener. However, this is not the limit to what you can achieve. This recent one, this particular company, Functional Foods, American Functional Foods in Winnipeg, secured over $100 million in a combination of government grants, loans, and also low interest loans from the Crown corporations. So as long as you have the case, there most likely is the government funding for you. Now let's jump into the topic of our discussion today and go through the software, government funding for software and hardware implementation. I wanted to start with a pan-Canadian initiative called Canadian Agricultural Partnership. This is in fact not a single program, it's an umbrella of multiple programs. And some of the programs, they cover the implementation of the software solutions by Canadian agri-food sector. So even though the name of the program has agricultural in it, it doesn't mean that it's just for, say, farms. No, not necessarily. It is also for food and beverage manufacturers. So if you are in the sector and the maintenance problem is high on your list of priorities, then you can definitely tap into this program and get some money to help you with the purchasing and implementation of such system. The intake dates vary from province to province. I would refer you to the your provincial portal for the Canadian Agricultural Partnership in order to find what the next intake date is for you. Another option is the Ontario Automotive Modernization Program. Obviously, it's only for those companies located in Ontario and those who are in the automotive sector. But keep in mind that it's not for GMs of the world and Fords of the world. This is for small to medium-sized suppliers to the automotive industry. And this fund specifically provides the funding for software implementation and lean training. This fund has two priorities. In terms of the amount of funding, it can get 50% of the project expenses up to a maximum of $100,000. At this time, the program is closed for applications, but we expect to resume this spring. There is also a similar program in Quebec, but it's actually even better for every type of manufacturing and technology company, so they don't necessarily stick to the industries. If you are located in Quebec and you have software implementation needs, you can get 40% of your project expenses, up to 50,000. And then there are similar programs in Prince Edward Island that provides 40% of the project expenses, as well as Newfoundland and Labrador, 75% of the project expenses, up to $100,000. Now, typically, is a huge part of software implementation project is skills training. It takes time to train people how to use the systems, and more time to train them how to use the system more effectively and efficiently. So on top of, and in addition to the funding for the software implementation, you can also tap into the funding for skills training. And there are a couple of options here. The first one is Canada Job Grant. Now, this is the also Pan-Canadian program that runs coast to coast. For example, in Ontario, the name of the program is Canada Ontario Job Grant. In Alberta, it's Canada Alberta Job Grant. So in most cases, they're using similar names. However, in some provinces, they use alternative names. Don't ask me why, but that's the case. Anyways, the way the program works is pretty similar and consistent coast to coast. If you are a small, actually it's not a small one, it's business of any size and any industry, really across Canada with skills training needs, you can get up to 83% of the training expenses, and sometimes even 100% when you hire an unemployed individual and pay for the training of that individual. The eligible expenses, though, are limited to the third-party training fees. So this training has to be delivered by the third party, independent. It could be independent consultant, could be technology firm. In many cases, could be your vendor. However, there are some regulations about the vendors. And it could be also a publicly funded college or university. Right? So the good thing about this program is that the government doesn't dictate you what training to take and who should take the training. It's your choice as the employer. And then if you qualify, you can apply for it. Now, I put the deadline here of March 31st, 2020, which actually should be 2021, my apologies. And the reason I put it here is because this program is at the end of its cycle. It's been around for already 5 years, and it's at the end. It's at the end of its period. Now, the federal and provincial budgets, they come out next week, so we'll have to double check what will be the future of the program. Maybe they will change the name. Maybe they will change the rules. But most likely, this program will be continued. Because this was a very successful program, coast to coast, and there's no, I mean, I don't see the business case for the government to close it. The next program, now only available for the manufacturers located in Southern Ontario, it's called YVES Landry Foundation's AIM Initiative. This is the popular program for skills training, specifically technology skills, right? So most of our clients used it for software skills training when they needed to train a number of employees in using the systems. And this program provides 25 to 50% of the training project expenses, up to a maximum of $100,000. And what's good about this program compared to the job grant is that the job grant only pays for the third-party training. This program also pays a portion of the salaries and employees, salaries of your employees while they are on training. So imagine if you need, like, literally to train everybody, and it takes, I don't know, 3, 4, 5 days, sometimes 10 days. Guess what? I mean, I'm not talking about specifically APM systems, but sometimes if it's a huge software implementation project like ERP, right? You need lots of people and lots of hours to complete the training successfully. And this is when the programs like YVES Foundation are crucial. The intake is currently open, but act now because the funding from YVES Foundation goes away pretty quickly. We've just learned that they've opened a couple of weeks ago, and started working on some applications for our clients. But keep in mind that, again, as I said, in the past, YVES used to run out of money very quickly. Now we just discussed software and hardware type of government funds and the government grants and for skills training. I just wanted to highlight that this is not everything, and there are other government grants for other purposes, but it always has to be for a purpose. Your company does not qualify for the government grant just because, right? Because you exist, because you are in business. You always have to have a particular project in the area that the government covers, and that particular grant covers. So at this time, there are some grants for purchasing equipment. There are some grants for developing your export sales or export marketing. There are also funds for hiring people and for research and development, and even large-scale expansion, such as construction or expansion of the plant. So keep in mind that your software project may be a part of something larger, or like for example expansion. That's a good case. So even if there is nothing available for you at this time, or at the time when you will start looking for the programs, keep in mind that this cost may be covered by other programs, and keep in mind that the government does not provide operational funding. So something that you are expected to get from conventional financial institutions. And we are at the end of my part of this presentation, so I welcome questions and answers. And I also wanted to highlight the eligibility check form that we have on our website. It's a free tool that we've developed, and what it will allow you to do is to we'll find out what kind of government grants and loans are available for you, depending on your goals and depending on what kind of company you own or represent and what sort of business you are in. So this link will be shared after the presentation. And now it's time for Q&A.
Okay, thank you, Igor. That was a very informative presentation. And as promised, let me just do one thing. I'm going to share my screen. Yep. All right, here we go. All right, so as you see on the screen, we're now into the question and answer section. And I don't see any questions in the chat as yet, but I do have a couple of questions. James, I'll begin with you. As I listened to you, I could not help but notice, I'm a motor racing fan, but I could not help but notice that a lot of what you are speaking of was familiar to me from watching motor racing, especially Formula One. And fans of motor racing, and especially Formula One, are going to recognize a lot of what you spoke of as race telemetry, where we're getting data straight off the car. And indeed, a lot of it, some of it shows up in the actual coverage. We get things like braking, acceleration, G-forces, how much throttle is being applied, how much brakes. All right. But the other part of it is that we also recognize Formula One as being one of the most expensive motorsports around. So my question, I have two questions for you, and they are as follows. Can you give us an indication of the relative cost of this kind of technology? Because I'm sure that's going to be a major consideration for anyone from a racing team to a factory manager. And the second part of my question, again related to cost, can you give us some idea of the sort of cost benefit of using this technology?
Sure. Well, in terms of costs, you're right. The Formula One is certainly not the way you're going to run your family car. It's a little expensive. The devices being used there are highly specialized for that application. Of course, high-speed, mobile, capable of withstanding high engine temperatures, things like that. So they're not your typical industrial sensors. The telemetry systems that are used in Formula One, believe it or not, actually do get used elsewhere in mining, for example. It's already in use in mobile equipment in some mining operations. In terms of the costs, though, the device costs, the actual sensor devices in conventional condition monitoring did tend to be quite expensive. With the industrial Internet of Things, we are seeing costs go down. You could probably anticipate an installed cost in, say, a factory type environment of being around $100 a point. So you've got a sensor mounted monitoring several different parameters, say vibration, temperature, sound, and maybe around $100 a point for that installed. Of course, you've got lots of points. You may have several points on a piece of equipment, several hundred pieces of equipment, so it can add up. In terms of the benefit, you know, the big benefit in monitoring conditions and equipment is typically not from the savings in repair costs. You will, of course, save on repair costs because you're doing small proactive repairs as opposed to major fixes where something's broken. So there is a small cost savings, but the real benefit comes in the uptime that you get from it. So your reduction in downtime translates into additional productive uptime. And by having that, you have the ability to produce more of whatever it is you're making. Now, if your business is a very low margin, you may want to really look at this quite hard. But if you're in an industry where the value of your production is actually quite high and generates quite a substantial margin, then the costs of monitoring it are substantially low by comparison to that. So the big benefit comes in terms of what you're going to get in terms of uptime. Now, I did work about a year and a half ago on an example with a mining company, and we were looking at across the board at 6 mines. We did see from an overall asset performance management. So we were looking at reliability, maintenance practices, as well as some of this tech. The annual cost savings across the 6 mines was on the order of $100 million. So the revenue gains as a result of uptime was almost $1 billion. So that was substantial. Now that was gold mining, big operations, you know, so that's kind of on the big end of the scale. So, you know, each case is going to be a little bit different. And I would never suggest you monitor everything. I would only look at, say, your more critical assets and the more likely types of failures, the things that you have experienced in the past. I think those are the things I would be monitoring. So I'd cut down on how much instrumentation I put on these things. You know, Formula One, I'm sure they think real hard about whether they put a sensor on the car because they have to carry it around.
Yes, yes. All right. Well, thanks for that, James. To our attendees, I have unmuted you, or not unmuted you, I have allowed you to talk. So if you have any questions, just unmute yourselves and go ahead and ask your questions. And while you're doing that, I have a question for you, Igor. I know that, and this is for our audience's benefit, I know that when we get these monies from the government to pursue these various projects, we don't just get it with absolutely zero strings attached. It is attached to a particular project, and there are reporting requirements that we have to have some accountability. Could you tell us a little bit more about the reporting requirements for when we get a grant?
Yeah, perfect. Perfect question. And actually, in most cases, you only get the money when you submit those reports to the government, right? Because the government wants to know that you have spent the money wisely. So typically those reports, they are attached either to the milestones of the project or to the government fiscal year, or sometimes to the quarter, right, depending on the program. And then when that milestone, to file your report comes, typically you file the claim that has two parts. The first part is about the expenses that you incurred, and you prove the government that you've spent X dollars for X purposes. And then the second part is what you've achieved. And this is very important, because not only the government is interested in just giving you the money to buy the software for the sake of giving you the money. It's also about the results that you achieve. What kind of improvements you've gained as a result of software implementation, or as a result of skills training, right? How your productivity changed, how your cost of maintenance changed, overall profit margin. Maybe some grants like marketing grants, they provide money to help you market your company. So then you have to tell the government how many leads you generated using this money that the government provided you with. And so only after that report, that claim is approved by the government, only then you receive the money. That's typically how it works. Oh, you're on mute.
Yes, I muted myself there, but I'm back. Yeah, that's actually going to be a very important consideration for anyone who's doing their project planning. It's a particularly important part. We have to have accountability for everything, and as these are public funds that are being granted to us to operate our business, we do have to be accountable for it. And that is actually one of the services that Fair Grant Writing does offer. We can assist you with your report writing, and we have the added advantage of being reasonably familiar with your project, having helped you to write the application. All right. So at this point, I'm gonna open the floor. Does anyone else have any questions, comments, observations? All right. With that, what I'd like to do now is just to move straight to wrap up. And I'd like to thank James Ray Picknell and Igor Shigrin for being our presenters this afternoon. It has been a very informative afternoon, and you will be able to see the recording of this webinar on our YouTube channel in just a couple of days. Thank you all very much. Have a wonderful good afternoon.